let's be real for a second. When we talk about the global AI race here in the US, we usually fixate on exactly one thing, right? Who has the biggest pile of silicon? But this explainer isn't going to just rehash that same familiar ground. Today, we're exploring a rapidly changing, almost cinematic global tech landscape where the stakes are highly realistic and incredibly high. The bottleneck of AI is shifting, and it is shifting fast. We're moving away from an era of pure hardware dominance and stepping right into an era of hyper-specialized efficiency and completely independent tech ecosystems. Okay, let's dive into this. For years, the story was super simple. If you wanted to win in AI, you literally just needed tens of thousands of Nvidia GPUs. But there's a quiet, kind of uncomfortable truth that's starting to emerge right now. The real bottleneck? It's no longer just getting your hands on the chips. It's about energy. It's about massive data center capacity. It's about building an entire hyper-efficient stack from the ground up. Because think about it, what happens when the world's second largest AI market can't easily buy those top-tier US chips? They don't just throw their hands up and stop building. No, they start innovating in completely different directions. Section 1. The new AI hardware race, photonic shortcuts versus brute force computation. And this brilliantly illustrates exactly what that looks like. While the US undoubtedly leads in advanced traditional silicon, researchers over at China's Tsinghua University are opening up a completely new front using actual light. So contrast in Nvidia A100, which is essentially this massive heat-generating power plant of the AI world, with new photonic AI chips, specifically systems like LightGen and the hybrid accelerator Axle. These things use light waves for optical inference. Now, to be clear, they aren't replacing Nvidia. They can't train some massive trillion-parameter language model. But for specific visual and generative workloads, they are over 100 times faster and vastly more energy efficient. It's literally like bypassing that massive power plant and just rewiring a neighborhood grid to run flawlessly without all the waste. That right there is the key takeaway for how this whole global landscape is evolving. By simply choosing the right compute for the right job, nations that are facing older fabrication labs and intense trade restrictions can just bypass those traditional choke points entirely. Sanctions, they just don't land quite as heavily if you've engineered a hyper-efficient shortcut for the exact task you're trying to accomplish. Section 2. China's independent AI ecosystem, building the end-to-end closed loop. Let's move to and see how this builds, because hardware is honestly only half the battle here. To gain true, complete independence, you need a fully closed loop. And we're seeing exactly that in a major new collaboration between the AI startup Zhipu and tech giant Huawei. At the very base, you've got domestic hardware, the Huawei Ascend Atlas 800 T2. Sitting right on top of that is Huawei's own AI framework, MindSpore. And running on all of this is Zhipu's newly open-sourced multimodal model GLM-Image. You see, this wasn't trained on Western hardware and just ported over later. The entire pipeline, from data prep to inference, was built and optimized specifically for this domestic stack. And the crazy part is, they didn't just build some basic, bare-bones model. They hit state-of-the-art performance using a really unique architecture, a hybrid autoregressive plus diffusion decoder. Now, instead of your standard diffusion models that basically just know how to paint a pretty picture, this specific architecture weaves language and imagery together natively. It creates an AI that deeply understands complex, real-world relationships, stuff engineers call knowledge-intensive scenarios. To actually pull that off, Zhipu and Huawei had to squeeze absolutely every single drop of performance out of that hardware, pushing it right up to its physical limits. But here is exactly why US markets and enterprise leaders should be paying very close attention right now. This is not some academic science fair project. Zhipu's API pricing to generate a single image on this entirely domestic stack, it is roughly 0.014 US dollars. That's right, a little over a single penny. That is mass-scale deployment pricing. This ecosystem is aggressively priced and clearly signaling to the rest of the world that it is absolutely ready for commercial adoption on a massive scale. Section 3. Google upgrades AI video, pushing VO 3.1 into the application layer. So pivoting back to the US, our tech giants are aggressively moving up the stack, directly into our everyday workflows. Google just made this massive distribution play with its AI video generator, VO 3.1. They're integrating these upgrades exactly where the attention is. We now have reference image prompting, which, thank goodness, finally fixes the clunky, frustrating mess of trying to perfectly describe a visual scene with just text. It also natively spits out vertical video now, which is basically mandatory if you want to compete on YouTube Shorts or TikTok. Add in crisp 1080p resolution with 4K upscaling, and you suddenly have a very real production tool. But arguably the smartest move here? SynthID. Google is hardwiring digital watermarks right into the output. They're embedding authenticity directly into the ecosystem, proving this whole thing is about building trust and verification, not just generating cool clips.
Section 4. Medical AI gets workflow ready. Gemini 1.5 tackles the clinical stack.
While video generation is definitely flashy, Google also quietly dropped a highly specialized AI designed specifically for healthcare. So the crucial point is that Gemini 1.5 isn't just looking at flat 2D JPEGs. It is natively processing high-dimensional 3D CT and MRI volumes, alongside massive, incredibly complex histopathology slides. And for all the enterprise IT folks running hospital networks, it works directly with DICOM files. That is the standard radiology format. That means absolutely no clunky custom pre-processing. It literally speaks the hospital's native digital language out of the box. The numbers here are just truly staggering, especially when you think about the daily grind of a physician. Just look at the audio dictation. Google released MedASR alongside Gemini, tuned specifically for clinical audio. Compared to the widely used Whisper v3, word error rates dropped from over 28% down to just 5.2%. That is an 82% reduction in transcription errors for critical things like chest X-ray dictation. Plus, lab report extraction accuracy jumped massively. I mean, this isn't just some incremental software update. This is a domain-specific takeover that is going to radically streamline how hospitals operate every single day.
Section 5. Smart Glasses Challenge Meta, the Rokid Wearable Offensive at CES 2026.
AI is rapidly converging right onto our faces. Now, in the US, consumers are intimately familiar with Meta's Ray-Bans. They are the reigning heavyweights of this space, for sure. But a global challenger named Rokid is stepping into the ring with a strategy aimed directly at Meta's dominance. It really proves that the hardware battle isn't just happening in massive, chilled data centers anymore. It's happening right on our noses.
Now, what's really interesting about this slide is the sheer level of miniaturization. Launching globally for just $299, these glasses weigh a microscopic 38.5 grams. That is nearly 20 grams lighter than Meta's. Inside, they are packing a dual-chip architecture to perfectly balance battery life and AI processing, supporting real-time translation in 89 languages. But the real wildcard here? They have integrated biometric payments through Alipay. You literally just look at a QR code, verify it with biometrics on the frame itself, and pay. No wallet, no phone required. So we have looked at everything today, from photonic light chips completely bypassing traditional GPU bottlenecks to fully independent Chinese AI stacks, to Google embedding native AI right into our hospitals, all the way to incredibly lightweight wearables reading QR codes. And it brings us to a critical final question. In this highly realistic global chess match, when the future demands the absolute right compute for the exact right job, will hyper-specialized efficiency quietly outpace the sheer brute force computational dominance we've relied on so far? It is a fascinating shift, and one that completely redefines what it actually means to win the AI race. Thanks so much for exploring this with me today. Keep asking questions, and I'll catch you in the next explainer.